So exercise 6 is definitely the most difficult one in the entire section. So I strongly recommend, if you are somebody who's looking to get like a high A on the next test, that you pause the video, try it ahead of time, and see if you would have been able to get this question if it were extra credit on the exam. So reading through this question, we've got some information about a machine, which we can see, as we've been told, we got our normal distribution, so we know we're using our good friend the normal. The mean is mu, that's weird, and the standard deviation is 0.4 milliliters. If more than 6 are milliliters of dye are discharged and making a particular shade, the shade is unacceptable. So it looks like here, more than 6 milliliters, we've got sort of a direction, right? We've got our more than, and we've got a cutoff. So we've got our x. So if we really want to think of this, something about probability of x greater than 6, or we can already start thinking about our drawing maybe, going, okay, I don't know what the mean is, but I do know more than 6 is unacceptable. And but right now, I don't know what that percent is. And then it says determine the mean amount. So we want to find the mean, okay, so that only 1% will be unacceptable. So now they're telling us, okay, more than 6, that's the unacceptable. Oops. And I'm going to assume that that's a small percentage, because otherwise that would be a lot of paint they'd be throwing away. And now they told us that they only want this to be 1%. So we want this to be 1%. So, well, you can see it's still our tricky inverse, right? We've been given a percentage. We're looking for one of our parameters, so we can't use normal CDF for inverse norm in its traditional way. We've got to work through those steps. We're going to use that percent to find our z-score, which means we're going to be doing inverse norm. 1% was a right side probability, so we're going to use the 99% on the left. If we need to, we're going to put in the mean of 0 and standard deviation of 1. So let me grab that z-score. .99, huh? Should get out a z-score of 2.3263. 2.3263 is our z-score. So remember, that's all about some underlying standard normal distribution. So we know exactly how many bunny hops this would have been. It'd be over 2 bunny hops away. And then step 2, we're going to turn that z back into one of our parameters, in this case our mu, by using that sweet formula. X is equal to z times sigma plus mu. This is on the formula sheet. You don't have to memorize anything. You just need to know what plugs in where. 6 is our x, it's our observation. We just found that z-score. They gave us a standard deviation. The only thing we don't have is the mean, which is what we're looking for. So we can go ahead, figure out what this piece is, subtract it off, 9305. Giving us our final piece that our mean is equal to 5.0645. And this time we actually do have units. This is all about milliliters. So that's what they should set the mean at, so that way they only end up with 1% of the paint being unacceptable. So that's pretty much as hard as the normal distribution questions can get. You will see this. There are a bunch on the worksheet that you'll be doing in class this week. I'll leave exercise 7 for Professor Steele to do with you guys as an example. And yeah, so if you have any questions, email me. Woohoo! Oh, my husband is a dork.